Here we have a problem on compound interest. Okay, let's go to the information. Peter received a loan of $15,000 at 12% per year compounded annually. He repaid $7,000 at the end of the first year. What amount should he pay at the end of the second year to completely discharge the loan? Okay, now first let me draw a line which represents a given situation. So here I have drawn a line. Let me write 0 here, and here I am writing 1, and here I am writing 2. So this 0 represents present. Okay, this 1 represents the end of the first year. This 2 represents the end of the second year. Okay, so Peter receives a loan of $15,000. So like we have to assume that present he receives a loan of $15,000. Let me write it over here. Okay, so this 1 represents the end of the first year. So according to the information, at the end of the first year, he paid, he is paying $7,000. And the remaining money is going to pay at the end of the second year to close the loan. That's what we have to find, how much he has to pay at the end of the second year to completely discharge the loan. Okay, since it's a problem based on compound interest, we can use a formula of compound interest, that is A equals to P times 1 positive R divided by N to the power of N times T. Okay, now let's understand the components of this compound interest formula. So this A is the value of the money after T years, and this P is the initial value of the money. This R is the rate of interest in decimal. This N represents the number of times the interest compounded in a year. Okay, so here we know that what is A? A is the value of the deposit after T years. Okay, P is the initial value, R is the rate of interest. Actually, N means the number of times interest is compounded in 1 year. So here it is given that interest is compounded annually. Annually means like once in a year the interest is compounded. In that case, the value of N is 1. So in case if the interest is compounded semi-annually, that is once in 6 months, the interest will be compounded. So that means in 1 year, interest will be compounded twice. In that case, N will be 2. If the interest is compounded quarterly, there are 4 quarters in a year. That is, the interest is compounded 4 times in a year. In that case, N equals to 4. But in our problem, interest is compounded annually. That means once in a year, interest is compounded. So N is equal to 1. That is, number of times interest is compounded in just 1 year. Okay, now what we have is we have to find the value of the loan, this $15,000 at the end of the first year. And also the question says the rate of interest per year is 12%. That is, interest is charged at the rate of 12% per year for the first year and also the second year as well. Okay, so the decimal form of this 12% is 0.12. Okay, now let me find the value of this loan, $15,000 at the end of the first year. That is adding a 12% interest rate. Okay, let me do it with the formula. So this A represents the value of the loan after 1 year. So we have to plug in T is equal to 1, and also we have to substitute the values for other variables as well. Okay, so since this P is the initial value, that's a loan amount, that is 15,000. Times 1 positive. So the R is rate of interest, the decimal form is 0.12, and N is 1, because we are going to find the value of this loan at the end of first year. That is T is equal to 1, and again N is equal to 1, T is equal to 1. So here I am taking N is equal to 1 because interest is compounded annually. Only once in a year interest is compounded. So since this N represents the number of times interest is compounded in a year, it is equal to 1. Okay, now let's evaluate the numerical expression we have over here. 15,000 times 0.12 divided by 1 is 0.12. When I add it to 1, it's 1.12. Raise it to the power of 1 times 1 is just 1. Whenever the exponent is 1, we don't have to mention, we can leave it. Okay, now what we have to do is we have to multiply this 15,000 and 1.12. When I multiply them, I am getting 16,800. So that is the value of the loan, $15,000 after 1 year, the rate of 12% interest. So it's $16,800. So let me write the stuff over here. So $16,800. So this is the value of the loan at the end of first year. But in this $16,800, Peter is paying $7,000 at the end of the first year. So to know the remaining, to know the balance loan amount, what we have to do is we have to subtract this $7,000 from this $16,800. Let me do it. So when I subtract 7,000 from this one, I am getting $9,800. So this is the balance loan amount he has to pay at the end of the first year. So, but he is going to completely discharge the loan at the end of the second year. So for that, we have to find the value of this loan amount, $9,800 for the next 1 year. So since it's a compound interest, every term the principal will change. The end of the first year, the balance loan amount is $9,800. So this is going to be the principal for the next 1 year. That is before the end of the second year. Now we have to find the value of this loan amount, $9,800 at the end of the second year. That is for this 1 year time period. For that, again, we have to use the same formula here. Let me write it. A equals to, now the principal is $9,800. I mean, the value of this P is 9,800 times 1 positive. So the value of R is again 0.12. That is 12% rate of interest. So 0.12 divided by, and so here n is again 1. That is number of times interest is compounded in a year. And here again we have to plug in n is equal to 1 times the time period is 1 year, because this time period is just 1 year. From the end of the first year to end of the second year, that is 1. So then we have A equals to 9,800 times, so 0.1 divided by 1 is 0.12. When I add it to 1, I'm getting 1.12. Raised to the power of 1 times 1 is just 1. Okay, the exponent 1 we don't have to mention. Now what I have to do is I have to multiply this 9,800 by 1.12. When I do so, I am getting 10,976. So at the end of the second year, Peter has to pay $10,976 to completely discharge the loan.